Hey, I'm Kimani, and today I'm going to be setting up a water-cooled spindle on my Onefinity CNC. So let's start with the VFD. This is the control module for your spindle. So all your settings are here. This is where everything's going to get wired to through this access panel. So once we get to that part, I'll show you how all that's set up. But this is the brains of the operation. Next up in the box will be the spindle itself. This is a very hefty beast of a spindle. I think this weighs around 20-ish pounds, so it's all just solid, heavy metal. One of the perks of getting a spindle is that you can use different collet sizes. So with your typical routers, you're stuck with usually a 1/4 inch collet, which is that piece in there. But with spindles, you usually are able to easily swap out the collets for different sizes. You'll also get like a small aquarium water pump. That's to provide coolant to the spindle. And you get this orange 5mm hose to connect all your tubing. And of course, the instruction manual. So that's all the stuff that comes in the box. Now let me show you all the stuff that doesn't come in the box that you're going to want or need. So first up is cabling. So I showed you everything that was in the box, and you may or may not have noticed there were no power cables. So you will need to buy your own cable to connect from the spindle to the VFD, and then another cable to go from the VFD to your outlet. For the spindle connection, I found this cable, and basically you have 4 connectors that connect to your spindle. So I found a cable that came with 4 connectors. It also is braided shielding inside so that any electromagnetic interference that could build up between the VFD and the spindle won't transfer over to any of the other electronics, and you shouldn't have any weird ghost in the machine type issues. So this is the cable I've decided to use and that I found. I'll try to put the details about this below. It does cost more than your standard cable, but like I said, it's all 4 cores, and it's shielded inside, and it's a flexible cable that's made to work with VFDs. So going back and forth, running the machine won't cause any breakage in the wires. So it's kind of worth, you spend enough money on the machine, it's worth the added expense if you're doing the upgrade. Then you will need your standard 3-post connector power cord. If you have a power cord at home that you're not using, or extension cord, you can always cut it. This was a couple of bucks off of Amazon for a 9-foot cord that was already bare on the end, so I don't have to cut a cord. A collet. You will need a collet. There is one in there, but depending on the size of the bits you use, you will need to get one that fits. This is if I can focus on it for you. There we go. A ER20. So this one is designed to work with 1/4 inch bits. So you'll have to look, I mean, different brands make them, but you'll just have to find the brand or the size code that matches the type of bits you're using. So I bought this one. I'll need to buy a couple of more. Usually these things are in metric, and most of my bits are in imperial. So, you know, you'll need to make sure. But ER20s are for 1/4 inch bits. If you want to have the Onefinity control your VFD, you're going to need a breakout board. You can buy one of these off the Onefinity site. I bought this one off of Amazon. It's a DB25 is the code name, so that's what you'll need, but it'll do the exact same thing. And you'll just, you know, if you have some extra wiring, standard, I think 16 gauge, 18 gauge wire should do that to wire that up. This is a VFD extension module. So basically what this does is that the controller module that I showed earlier can pop out, fit inside of here, and then run this extension cable, so that way the actual housing of the VFD will be you know, against the wall or away from the machine, and then you can actually keep the control module closer to you on your tabletop. So if you need to adjust your power settings or emergency stop or turn it off, all those switches and controls are closer to you while keeping the main housing unit and all its running parts away from the surface area. So this is also a little extra. Like I said, I'll put all that in the details below. So, and of course you'll need a bucket, some water, some distilled water, or whatever fluid you choose to run through your spindle, soldering iron, and wire strippers. So all this is what you will need to get started and get your VFD up and running. So first up, you need to cut some wires and solder some connections. So before I begin, full disclosure, I am not an electrician. I have soldered more copper pipe than I have ever done any electronics. So this is in no way me showing you how an expert does it. This is me showing you how a guy who's looked up how to solder things a lot on YouTube is going to do it. So I've looked at the right ways and the wrong ways to do it. I'm going to try to do all the right ways and show a finished product that works safely. So, take that with a grain of salt. If you don't feel comfortable doing any of this, maybe you have a friend or know someone who is an electrician and has all these tools so that you don't have to buy them and can do it for you. You know, $20 or a case of beer usually goes a long way to get this done fast and right. Another note before we get too far into it. I have the Huanyang 2.2 kilowatt running 120 volt system VFD. Now I've seen a lot of debate when it comes to the wiring of these things. So it has 4 pins. Pin number 4 is generally the ground. Some people were stating that that pin is just there, but there's actually no wires or anything connected, so you don't have a dedicated ground running inside of your VFD. And then there's some extra steps that you'd have to take to make sure that this gets grounded. I actually just went ahead. I bought this in August of 2022. So when I took this off just to see, all 4 of my wires are actually grounded. So I would just say, if you're buying this obviously after August of 22, before you get started, you can always take these off, open this up, and make sure all wires are connected, and that way you'll know that you are actually connected to some sort of ground on the inside. Okay, so we start with this connector piece. If you can see there, it's numbered 1 through 4 on the connectors. And we have these little connection points here where we're going to drop in the 4 cables. So I'm going to show the cable and how those connect. So this is the cabling. I've taken off the braided shielding so I could just get to the actual 4 cables there. And so I'm going to start off by exposing a little bit of the wire, and I'm going to tin it. And tinning is basically where I expose some of the wire and then I apply a little bit of solder to the tips of it so they have kind of like, silver tips. That makes it easier if I need to like snip the cable. I don't get all those loose threads everywhere, little loose strands of copper. And when I'm putting it together with the other piece, hold on. When I'm trying to connect these two together, I don't have to worry about the cables being frayed and bunching in. They should be able to fit inside of each one of these, and then I can run the solder and get a better connection for both. So I'm going to start that process. Okay, so I have tinned the wires. This is my first time doing it, so there was a lot of trial and error of knowing how hot to get the soldering iron and whatnot, but I got it. I don't know if it's exactly right, but it looks close enough to what I've seen, so I think it'll work. The wires are coated fairly evenly. I just had to get the soldering iron hot enough to actually really melt it, and then I just kind of like melted a little solder on the tip and kind of like rubbed it across, and it just kind of melted through the wiring and gave it a nice coating. So that's tinning the wires. I gotta do it again, so I'll try to actually show that process and show the cord unraveling. So yeah, there you go. Okay, so what I'm going to do here is take that. This is numbered 1 through 4. I'm going to make the green cable number 4, and these other cables are actually numbered 1 through 3, so I'm just going to match them up, because that way when I cut the other end of the cable, all I have to do is match 1, 2, 3 with the connectors on the VFD, and everything should be good with the green going to the ground. So I was getting ready to solder everything together, and I just didn't give myself enough room to play with. So if you look closely, that's the braided metal shielding that goes around everything. So as you start to cut this, it starts to fray everywhere. So I would say it's good to have some sort of like masking tape to kind of tape around there to collect all the little metal shavings that come off when you do that. So yeah, I'm going to shave that off to give myself more breathing room with these cables. That way it's easier to get inside of these aviation connections, and then we'll go through the rest. Okay, so now that I've stripped back the cables a little bit, gave myself more wiggle room there, and I put the little sleeve back on from there. One thing I noticed is that they're all black, but you can faintly make out they're numbered. So that's the 3 on that one. The green, this is the green, but there's a 1 on this one. So when I have to cut the other end, even though I'm going to put shrink wrap tubing on here, when I cut the other end, I should be able to see the 1, 2, and 3, or at least the 1 and 3, and I'll know which one's 2, to connect to the VFD motor. So, yeah, that was the 3 and a 1. So. Now I'm going to put on some shrink wrap tubing on each one of these, just as a little extra protection once I start to solder, because once again, I am not a professional at this, but you know, I've watched enough safety tips to try to do it right. So green is my number 4. Everything I've looked at says that is correct. So I'm going to get a little clamp here. I'm going to use my Bessie clamp here to hold this steady for me. Have another set of hands. And let's see, so that's 4. That's where I want to solder into. So it's in here. No, this one. Here. Really? It's not pretty, but it will hold. So now I'm going to drop all the shrink wrap down and cover all of those up, and should be good. Alright, so here's where I am. So I have my shrink wrap on my tube. So everything is double protected, so it's tinned and soldered in there, and then it's all shrink wrap. So just in case any mistakes I may have made, they're all nice and covered up. And just remember to, before you start to solder, pull your shrink wrap tube up high enough here, and make sure you have shrink wrap on all 4 cables. And then go ahead and solder your connections, and then slide down your shrink wrap and heat it. So then I'm going to move this collar a little down. It's easier to do with 2 hands, so just going to move the collar down, and then get that down till I get to the point where I can start to screw those together. I may need a little bit more slack in here, so just keep sliding that down. So this will screw together nice and secure. Make sure it's not bunching up. So make sure this ring is on before you screw this down, or you'll have to do like I did and take this off all the way around and then slide this back on. So it should connect like that when you're really done, and then you'll put the other piece of the collar on. So yeah, I got partway through and realized, oh, I forgot to put this ring on. So yeah, this is the ring that actually screws it into the top of the spindle, so let's not forget that. Alright, so before I pull off all the coating, show you that a braided shielded cable. So yeah, so you got your 4 cores in there all wrapped around this shielding. Like I said, this is supposed to help with electromagnetic interference, and I've cut about 2.25 inches down from the end, and that's so when I put it into the VFD controller, I have some flexibility with my cables. And like I said, this braiding is all, metal braiding, so wrap some masking tape or tape around here when you start to, and I just take a sharp, blade and just slowly, and don't go too deep because you'll cut into the wires, but just to score across there until the strands start to break apart. Just go all the way around the cable, and once they all break apart, you just kind of slide it off, and there's another plastic housing around that, and I actually just take a small slit towards the top and it kind of like peels apart. So yeah, just be careful, you don't want to get metal shavings in your fingers while you're doing this. Kind of takes away from the experience. Alright, so as you can see there, you have the metal braid, and then another thin protective shell, and then bare wire. So, like I said, be very careful as you just kind of score across the metal shielding. You really just want to kind of break the tension in the wires. If you go too deep, you're going to go through that plastic coating and then cut into your wires below. So just, be careful when you're doing this part, or you're going to have to, go a little further down and cut some more cable. But yeah, that's the important part, is just kind of be slow and deliberate to make sure you don't cut into your wires. So I got my wires stripped, and I'm going to cap them with these little guys. These are 16 gauge. I'll get the right sizing for you, but basically I'm going to tin these, cap it, crimp it, and then they're just going to screw into the VFD. So as I mentioned earlier, part of the reason for tinning the wire is that when I slide this on, I see that a lot of it sticks out. So what I'm able to do is cut about half, and I have no frayed wires. No little pieces of copper or anything. It just snips down, and then all I have to do from there is twist this back on, and I can see a little bit right at the top where I need it for connection purposes, and just crimp it down. Get a nice snug connection. And then I'll just do that to the other 3. Nice tin connection, no frayed wires, just a little bit poking out. do that with the others. Cut you in half, but yeah. Okay, so now we have the VFD, and so I've already removed the 2 screws here so we can see inside. So right down here you see a sticker that says motor. So, and on the bottom, this is kind of where our cables are going to feed through, so you can actually just pop that out. Easy access. So we're just going to cut a slit in there and probably leave this alone for now. And then maybe plug something in there later. And then I'll just remove the sticker that says motor. Because it says U, V, and W are what we plug our spindle into. And 9 over here are going to be our grounding wire. So let me get that into place. But first, I'm just going to take out these 3 screws right here. Actually, I'm going to take out these 4 screws right here. And then we're going to go over wiring and proper placement. Red guy, ground wire. Okay, so earlier, you know that our adapter is labeled 1, 2, 3, 4. When I did the wiring for it, green was my number 4, and then the cables actually numbered themselves, so I just matched it up to 1, 2, 3, 4. And then on here, probably do a zoom in shot, but I can see my green, and then my 2, my 1, and then my cable 3. Now, nowhere on here is 1, 2, 3, 4. So I had to do a lot of digging and research because there were no instructions that came with this that tells you exactly what matches to 1, 2, 3, 4. But I found it. I'm going to throw the diagram up here that I found and that I'm going to be using for this to follow, I believe it's 1, 2, and then 3, actually. So the diagram that I found labeled this as U is 3, V is 1, and W is 2. So my cables, my 3, my 1, and my 2. So what I'm going to do first is I'm going to cut a slit into here so I can run all of my wires through, and then through here to connect to my 3, my 1, and my 2. Okay, so a little trial and error. I'm in there, my 3, my 1, my 2, and my ground. So there's another, I'm going to slide the power cable up next when we get to that part, so I'll leave this down for now, but we can go to wiring the power cable, which will be a lot easier. Alright, So this is a standard power cable. Like I said, I picked this off Amazon. Just wasn't terminated on the end because we're going to terminate it. So I'm going to slide this. Well, I'm going to go and tin the wires on this, put on these guys, and then it's going to go black to R, white to T, and then green, as usual, grounding cable over there. So gonna go ahead and I'm just do all of that off camera because you've seen it all already, and then I'll just show you the wiring when it's done. So the connection for this really matches in and plugs in a particular way. So you'll just find the way the grooves fit in. Get snug fit. Tighten everything down. Okay, so that's connected. And now I'm going to plug this in. Okay, so when you plug it in, it automatically powers on. There's no outward power switch for this. I can show the screen. So that is the default. And so what I'm going to do now is I'm going to just without getting into any configuration or anything like that or changing anything on the screen, I just want to make sure that the spindle connection works if I tell it to. So alright, so we're at 18, I believe this is in hertz, so we're at 18 hertz. I think you can program it so you'll actually see the revolutions instead of hertz. I'll get into that later once I read up on it, but yeah, we got spinning on the spindle, so that means we are good. I'm going to stop that. And spindle turns down. Now I'm going to turn all this off and disconnect it, and set it up on the CNC table so I can do the water, and I'll configure this part later. Okay, so I have the spindle mounted in the Z slider. The VFD is sitting over there for now until I figure out where I exactly want to mount it. So now we're going to get our water pump and system set up. So for that, you'll need a bucket or somewhere where you're going to hold your liquid of choice, and your rubber hoses. Okay, so I'm going to start by taking these off. And you're going to just put this over the end. Like I said, it might be a little snug, but you want snug. Just kind of bring that down. And then you're just going to go right on top of here. And you're going to have to work it. But you want to get down over the flare. Okay, so it's nice and snug down over the flare of the connection. And then we're just gonna bring that down over. Make sure we're good in there. And just droop that behind. And then do the exact same thing with the orange one, or if you decided to get this clear tubing, you know, do the same thing. So I'm just gonna do that real quick and I'll be back. Oh, and I don't know the exact length on there. I'm sure it probably tells me in the Amazon description, but I'm basically just going to stretch this out, fold it in half, and cut it in two. Just in case I ever, you know, something bad happens to this, I'll have another half of this to connect in case of emergency. But yeah, I'll do that. Come back, connect, and we'll get into the bucket. Okay, now that the hoses are connected, what I'm going to do next is get my bucket ready. I'm going to drill 2 holes in here, roughly the same diameter as this. I don't want to go too much larger because I don't want to, you know, risk more waves that dust or debris can get inside. You can also buy rubber grommets that'll fit inside that hole. That'll actually help keep that from happening. I didn't pick any up yet, so for now I'm just going to put those in, and then I think I'm going to just notch right into here on the bucket for the power cord instead of trying to make a hole the size of this. It's probably easier for me to just make a notch or drill a smaller hole right there, and then I'm just going to cover all this up with a little bit of tape anyway, just to make sure there are no holes available for dust and stuff to get into. So now I'm gonna get this ready. These are the rubber feet that came in the box. Get those in there. Oh, the feet obviously work. So this thing doesn't have like an on-off switch, but it does have a dial here that I guess controls, you know, the force of the pump action. So, you know, negative to positive just increases how strong it is. So I'm gonna set it 3/4 of the way, and then set it in my bucket. And let's get some liquid in there. Does not want to go on there easy, so you really gotta make sure it's on there good. Put that back in there. And then get other holes. Nice snug fit. Just make sure that's deep enough in the bottom to actually touch the liquid. Let me put it in there. Okay. It's a 2-gallon bucket, so, you know, gave myself a little room in there. But the cord's underwater. Everything's good. Okay, so everything's connected. Got my clear hose, got my bucket, got the pump inside. Now I'm just going to plug it in and see if we can see some pink fluid running through this whole system. All right, we got fluid. Looking around, everything is tight. I have no leaks. If you've ever had an aquarium, it's just a slight hum that you hear, but this is going to go under the workbench, under the table, so with the router and everything else going on, you really won't hear it. But yeah, no, everything looks good. So, okay, let's figure it out from there. Okay, so final step before we do any sort of configuring is to make sure everything works together. So, got the water pump going, I got the spindle connected. Now it's time to plug everything in, turn it all on, and let it run like it normally would. So, here goes. Hey! So this is me talking with no additional microphone except for what's on the camera. The spindle is on, the VFD is running, and the water pump is humming under the table. So automatically, like, you're noticing an immediate drop in noise in the shop. Now, A lot of that will be negated once you actually start carving into material, but the devices here are all making less noise than one of these standard routers that would go in here. So that's a win already for anybody who doesn't like loud noises. Alright, well, with that, you are pretty much set up to run your spindle and VFD. So we know that the VFD works, that the spindle works, the connection works between them, our hose and our liquid is pumping, and there are no leaks, so we're pretty much set. So if you want to manually control your VFD, you can probably set up a program and run it right now. If you'd like to have the Onefinity controller control your VFD, I'm going to do a follow-up to this one that shows you how to use the breakout board and get everything else configured in your VFD for it to run through the software. A couple of things of note. The orange tube, I'm going to change that out. Just purely off this setup, it's very rigid. So I'm going to change that out and buy another of the clear tubing and set that up. I'm getting about another 10 or 12 feet of that because it going back and forth to the table, this does not have as much give or flexibility as the clear tubing does. So I would probably suggest go ahead and swapping out this for another tube. So get yourself about 22 feet of clear tubing. I got that from my local Ace Hardware. It was 17 cents a foot. So yeah, I think the first round it cost me $1.17 or something like that. So yeah, I'll go spend another $2 and get a hose that has a lot more flexibility to it. Next up, like I said before in the beginning, I am not an electrician. There's a lot of soldering that goes into this. So if you are not comfortable with soldering wires and doing connections like that, I would highly suggest you tag in a friend or someone who knows how to do that kind of thing and just get that part over with. Just for peace of mind of knowing that the connections are done properly. So if you do run into any issues down the line, that won't be one of them. You don't want any wires that are just not soldered properly sparking inside the VFD or causing a short or anything like that while you're working. So just as a precaution, I did all of my own work just because, it's me, I could take my own risk. So don't say that the guy on the internet said just this is how you wire it up, because it wasn't me. And yeah, other than that, once you get past the soldering aspect of everything, it's really just following the directions and plugging everything where it needs to go, making sure your wires are grounded, and you're pretty much set. So it takes a while to get to that point, but once you're there, I mean, it's a pretty nice feeling when you hear that thing kind of rev up and everything's functioning. So thank you for watching. I appreciate your time. Come back for the next one where I wire up the controller for the VFD and get everything programmed in. And until then, be safe.